Let us perform some more activities to understand the chemical properties of acids and bases. Activity 2.3 explains the action of acids and bases with metals. For that, set up the apparatus as shown in figure 2.1. Take about 5 ml of dilute sulfuric acid in a test tube and add a few pieces of zinc granules to it. What do you observe on the surface of zinc granules? Pass the gas being evolved through the soap solution. Why are bubbles formed in the soap solution? Take a burning candle near a gas-filled bubbles. What do you observe? Repeat this activity with some more acids like HCl, HNO3 and CH3COOH. Are the observations in all the cases the same or different? Observation. The bubbles are formed due to the evolution of a gas during the reaction between acids and metals. Metal plus acid gives metal salt plus hydrogen. The gas burns with pop sound when burning candle is brought near the bubbles. The same gas, hydrogen gas, is produced in all the cases. That is, when the acids like sulfuric acid, hydrochloric acid and the nitric acid react with metal, in all these cases hydrogen gas will be evolved. The hydrogen gas evolves rapidly when the acid is strong and slowly when the acid is weak. From the above activity, we come to conclusion that when metals react with acid, hydrogen gas is formed along with metal salt. It is an example of displacement reaction. In the above activity, when acetic acid reacts with metal, the rate of reaction is slow as it is weak acid. Let us perform another activity to understand the action of metal on bases. Activity 2.4. Place a few pieces of granulated zinc metal in a test tube. Add 2 ml of sodium hydroxide solution and warm the contents of the test tube. Repeat the rest of the steps as in activity 2.3 and record your observations. Reaction of base with metals. We observe that zinc metal reacts with strong bases to give hydrogen gas and metal salt on heating. Zinc Zn plus NaOH, sodium hydroxide, on heating gives sodium zincate Na2ZnO2 plus H2. While balancing the equation will be Zn solid state plus 2 NaOH on heating gives Na2ZnO2 plus H2. Na2ZnO2 is sodium zincate. From the above activity, we come to conclusion that strong bases react with few metals to give salt and hydrogen gas. It is also an example of displacement reaction. Let us learn the action of metal carbonates and metal hydrogen carbonates with acids by an activity. Activity 2.5. Take 2 test tubes, label them as A and B. Take about 0.5 gram of sodium carbonate Na2CO3 in test tube A and about 0.5 gram of sodium hydrogen carbonate in test tube B. Add about 2 ml of dilute HCl to both the test tubes. What do you observe? Pass the gas produced in each case through lime water, that is calcium hydroxide solution as shown in figure 2.2, and record your observations. Observation. When sodium carbonate and sodium bicarbonate reacts with hydrochloric acid separately, it produces sodium chloride, carbon dioxide and water. In test tube A, Na2CO3 plus 2HCl gives 2NaCl plus H2O plus CO2. Na2CO3 sodium carbonate, HL hydrochloric acid, NaCl sodium chloride, H2O water, CO2 carbon dioxide. In test B, when we are adding sodium bicarbonate, the same salt, water and CO2 are produced. NaHCO3 plus HCl gives NaCl plus H2O plus CO2. Whenever you are writing the equation, you must indicate the physical state. When the evolved gas CO2 is passed through lime water, it turns milky due to the formation of calcium carbonate. The equation for the reaction is CaOH twice plus CO2 gives CaCO3 plus H2O. CaOH twice calcium hydroxide, CO2 carbon dioxide, then calcium carbonate CaCO3. On passing excess CO2, the calcium hydrogen carbonate is formed, which is insoluble in water. CaCO3 plus H2O plus CO2 gives CaHCO3 twice calcium hydrogen carbonate, which is insoluble in water. That is, it does not dissolve in water. Bases do not react with metal carbonates and metal bicarbonates since they are bases. Bases do not react with the bases.